Hey guys, my name is That Quiet Kid, and today we are going to do a room on Tryhackme, which is Introduction to Honeypots. It is a guided room covering the deployment of honeypots and analysis of botnet activities. So, what's a honeypot? It is like a trap through which you can attract hackers and you can record their actions. You can know what they are doing. So, let's start this machine, and to connect to the Tryhackme VPN. And to connect to this machine, you have to download the Tryhackme VPN. You can just go click on your profile, then you have to go to access, and from here you can download your configuration file, and then you have to type open VPN and your file. I have already downloaded it and renamed it. Okay, so deploy the machine. It's complete. Types of honeypots. It's a theory low interactive honeypots offer little interactivity to the adversary and are only capable of simulating the functions that are required to simulate service and capture against attacks. Examples are Dione and Melanie. Low interaction honeypots. So there are basically three types of honeypots. One is low interaction, the other is medium interaction, and last one is high interaction. So you can read the theory from here. So we will dive right into answering the questions. Read the above and understand. So deployment location, you can deploy honeypots two ways. First is internal honeypots, which are deployed inside a LAN, which is local area network. This type can attack. This type can act as a way to monitor a network for threats originating from the inside. So this is to check if there is a hacker inside your network or not. And next one is external honeypots. They are deployed on the open internet, are used to monitor attacks from outside the local area network. These honeypots are able to collect much more data on attacks since they are effectively guaranteed to be under attack at all times. So Kauri demo. So Kauri honeypot can work both as an secure shell proxy or a simulated shell. The demo machine is running the simulated shell. You can log in using the following credentials. The IP you can copy it from here, and it is root and password is any, so you can write anything for the password. So let's SSH into the honeypot. SSH, then the name was root at the rate IP. So okay, connection refused. I think it's running on port 22 or not. Let me see if I am connected. Okay, I am connected to Kali VPN. SSH root at the rate 10.10.209. Okay, why is it taking so much time? Try running some commands in the honeypot. It's taking a long time. So let's try from here as well. SSH root at the rate IP. But it's not working. Yeah. Okay, now it's working. The password was any, you can type any password. It doesn't require any password. So let's type password. We can write anything, it will automatically connect, show us a SSH prompt. Okay, so try running some commands in the honeypot. Okay, but it is a bit slow. Let's type password root here. Okay, so can we run ls? Yes, we can run ls, which is listing the files. Can we print working directory? Yes, we can. We are in root. So we can run some commands, create a file, then log back in it. Is the file still there? So we have to create a file and see if it is still there. Let's create a file name file.txt, exit out of this SSH prompt, and let's log in back and see if the file is there or not. Password, you can type anything. I will type root here. Okay, so let's list files and see if our file is there. No, it is not there. We can see the hidden files as well, but it is not there. Our file has been deleted. So we'll type recovery logs. Let's see this task 4 now. Recovery event logging. The honeypot won't be of much use without the ability to collect data. So it's collect data, and it we can see the data it has collected by connecting to the real SSH port. So this is the port 1400 is the real SSH port. By default the port for SSH is 22, but the 22 port has been used as as a honeypot. So this is the correct port through which you can see what the attacker is trying to do or what he has done. So let's exit out of it. So I guess demo was the user, and the port we have to specify it was 1400. And what's the password? The password is also demo. Yes, demo. Okay, shouldn't take too long. It's not working. Let's try from here. SSH. Okay. Okay, let's see. Yes, now we are in the SSH, the real SSH prompt. So what we can do now, have a look through the logs and see how the activity from the last task has been recorded by the system. So logs can be found at this location. Let's cd into this location and see the logs. Okay, let's cat out the logs. Dot. Okay, scat out json. Okay, what does it say? Okay, it is now we can see that it is showing our source IP from which we try to connect to this machine. The connection lost after 209 seconds. Okay, then we typed command ls and ls space dash la to list the hidden files as well. Is showing. Then we typed exit and we exited out of that honeypot. So so you can see the logs now. So let's move on to task 5, which is SSH and brute force attacks. By default, Kauri will only expose SSH. I think it's a type of honeypots. It's some medium interaction honeypots which collect data by emulating both vulnerable service as well as the underlying OS shell and the file system. This allows adversaries to complete initial exploits and carry out post exploitation activities. Note that unlike high interaction honeypots, see below, the system presented to adversary is a simulation. As a result, it is usually not possible for adversaries to complete their full range of post exploitation activities. So we cannot do the complete post exploitation from a medium interaction honeypot. So the example of it is Kauri, which we are using here. So let's see the attacks against SSH. The attack surface presented by a typical SSH installation is limited, so most attacks against the service will take the form of brute force attacks. So if you know you can guess the username and password through word lists. Defending against these attacks is relatively simple in most cases, as they can be defended by only allowing public key authentication, so that you have to specify a key before logging in, or by using strong passwords. These attacks should not be completely ignored, as there are simply so many of them that you are pretty much guaranteed to be attacked at one point. So we have a file which contains 200 most common credentials used against counter deployments has been left on the demo machine, and we have to answer these following questions. How many passwords include the word password or any other variation of it? Example. So we can check, okay, where we are. We were in, let's go to the root directory. Am I in root? No, I'm in his home folder. Yes. Okay. So top 200 credentials, what we have to find is how many passwords include password or other variations of it. So for it we will use grep, and we will specify, I guess, specify uh, p from, the syntax is dash I p, and it is from top. So let's see how many instances of password: 1 2 3 4 5 6 7 8, deploy 7 8 9 10 11 12 13 14 15 15 15 16 16 password. Let's see if we are right. Okay, 16 is not correct. Maybe let's try 15. Okay, maybe I counted the same word twice. So what is arguably the most common tool for brute forcing Hydra? It is simple, it's Hydra. We use whenever we try to brute force a website or a SSH or POP3, that is, yeah, that is used for email authentication or something. I don't remember what is it is, but it is it is somehow related to emails. And whenever I try to brute force anything, Hydra is the tool. FTP, SSH, port 80, port 440, anything. Hydra is the tool to go whenever you are brute forcing. What intrusion prevention software framework is commonly used to mitigate SSH brute force attack? So we have, I think we have to Google this. In intrusion prevention software framework, which is commonly, I think it's failed to ban, but let's confirm it. I learned it from an IPsec video in which he explained fail to ban is for preventing SSH brute force. Yes, fail to ban. It's failed to ban. Bans. Typical bot activities. So let's move to task 6. The majority of attacks against typical SSH deployments are automated in some way. As a result, most of the post-exploitation activity that takes place after a bot gains initial access to the honeypot will follow a broad pattern. So it is saying that if whenever a bot tries to attack, it follows a pattern. In general, most bots will perform a combination of the following. It's type uname to know the s- uh, you can say the system information, that what OS you are running. And nproc, I think it's shows the process information, I guess. So let's, what CPU does the honeypot use? So I have opened a shell here. Okay, it was closed. Let's open it again. Root password was anything. Let's type root again, and let's see uh, what was the what was our question again. What CPU does the honeypot use? We can know it by catting out this CPU info file, which is in proc folder. Let's type out Okay, it's Intel Core. Okay, copy this and let's paste it here. Okay, it is the correct answer. Does the honeypot return the correct value when uname minus a, that is the OS information, kind of OS information, what OS is running? Let's see if it returns the correct value or not. So let's run uname minus a, and let's run it uname minus a from here as well. It's showing Linux 4.15.0.158 generic, and it is showing Linux 3.2, so it is not showing the correct version. What flag must be set to pipe means to pipe wget output into bash. I guess it's dash o. So let's see. Yes, it is. How would you disable bash history using unset? So I think we will have to Google this as well because I don't know the answer to this. Okay. Okay, I think this is the command unset hist file, which is to temporarily suspend bash history. Okay, it is the correct answer. So let's dive into our task 7. Is it possible to use the data recorded by Coverage to identify individual bots? So let's see if we can identify bots, individual bots as well. The factors that can identify traffic from individual botnets are not always the same. However, some artifacts tend to be consistent across bots, including the IP addresses requested by bots and the specific order of commands. As they explained earlier, that bot always start with a pattern. So, what brand of device is the bot in the sample examples in the first sample example searching for? So let's see, where are we? WD. Okay, the bot information was in our shell, in our real SSH shell. So cd into bot commands. Let's cat out sample one. Okay, sample one. I'm using tab for auto completion. So what is the question? The question is, what brand of device is the bot in the first example searching for? So what is it searching for? It is searching for something. Let's Google this. What is it? What brand of device? Let's Google this. Okay. I think it's specifying its name. It's Microtic routers. Okay. Okay. For some reason, it's. Let's see if it has copied or not. Oh, it has not. It was macro. Yes, it is. So what are the commands in the second example changing? What are the commands in the second example? So let's cat out sample second. What command it is changing? It's changing the root. I guess it's changing the root and ch password. It's changing the root password. Am I right? Yes, I am right. What is the name of the group that runs the botnet? What is the name of the group that runs the botnet in the third example? So let's cat out example third. Okay, so what is it? I have no idea what is it. So let's Google this as well. What is the name of the group that runs the botnet? Name of the group. Let's Google this. Okay. What is the name of the group that runs the botnet? It's a six alphabet word. Okay. So what was it again? Which it's some kind of grep mem. It is looking for something called mem. So let's Google this. Okay. What is it? Okay, so let's try other tasks first and then I will go back to it. What application is being targeted in the first example? First, it's tunneling sample one, so cd into it, get out sample one.txt. So what application? So it's a web application I can know from here. As you can see that it's specifying host It is telling us the browser type, user agent, but it also has a file, this .php file. So let's see what kind of file is this. It's a WordPress file. So it is targeting a WordPress. What is the URL in the second sample malicious? So let's visit the URL, cat out sample2, and okay, I forgot to tap autocomplete. Request forward request to uh, ips-api.com. So let's visit this website and see if this it is malicious or not. Okay, IP geolocation app, free for non commercial use, no API required. Okay, so it seems like a genuine website and it is using HTTPS as well. So I think it is not a malicious website, I think. So let's see. Yes, it is. It was not. Okay. Recap. I hope this room has demonstrated how interesting honeypots can be and how the data that we can collect from them can be used to gain insight into the operations of botnets and other malicious actors. I have included some extra resources if you want to learn about honeypots, and the credit for making this room goes to CoolComputerMan. He is the guy who created this room, and he has also included some resources on botnets. I would also recommend that you deploy a honeypot yourself, as it's a great way to learn. Deploying a honeypot is also a great way to understand how to work with cloud providers, since external honeypots are best when deployed to the cloud. Deploying and managing multiple honeypots is also an interesting challenge and a good way to gain practical experience with tools like Ansible. So I think we left only one question of task 7, which was what is the name of the group that runs the botnet in the example third. You have to go back a directory. It was in bot commands. It was sample 3, I guess. So what is it? I have actually have no idea what group, what is the name of group that runs the botnet. Okay, I think I'm going not going the right direction. Let's type botnet. Cryptojacking attacks, but it's I guess Mirai botnet. It's 5 words, I guess, but it is 5 alphabets. It is 6 alphabets long. So let's keep digging. Outlaw. So let's see if this is the answer or not. Okay, it was the answer. So in this way I have completed this room and I have answered all the questions. And if you want to dive into botnets more, the cool computer man, let's see, it was CoolComputerMan has provided resources at the end of this room. I have answered all the questions and I have tried to explain everything except for some theory part, because you can read it yourself. The main point of making this video was to answer all these questions and try to explain how I find the answers. So that's it for this video, and thank you for watching.